This is the Crystal Clear Electronics video's 10th chapter and 4th video. In the last 3 videos we have introduced you to the C programming language. As we promised earlier, we will try out our knowledge in practice.
By now we are already familiar with the building blocks of the language. Let's see what a C program looks like. We will explain a program structure using the most known program, which is Hello World. Let's look at it line by line. Using the include on the first line, we can insert and import pre-written sections into. STDIO stands for Standard Input Output. The STDIO also includes the printf function, along with many others, which can be used to print characters to the standard output, usually a terminal screen. The .h tells you the extension of the file itself. The .h is the abbreviation of the header file. Such files contain prototypes of functions and constants. This is followed by the main program. Int main bracket void, which is the entry point for all C programs. It can be seen that this is essentially a function that will return an integer and has no input parameters. The function body is located between braces. We provide our codes with comments, as we did in the examples above, and we have to write our comments between slash and slash signs if we want to write comments over lines, but if we want to write a comment within a given line, we can do it by placing double slash signs. These are meant for us, who write the program. The compiler ignores these lines as if they were not there. This is followed by the already mentioned printf function, which has the text hello world /n within, which is given as a string. As a reminder, the strings are a series of characters. The /n means a new line. Besides /n, another important character is the /r. They are usually found together, and their meaning is, go to the beginning of the next line. These are called control characters. Finally, our program ends with return 0, which terminates running the program, and 0 indicates that everything has been successfully completed. As you can see in the next figure, if we compile and execute the program, the Hello World text will be printed to the terminal. Anyone can try executing this program, as there is no need to download anything because there are many C compilers available online. We also used a compiler like this. While I was explaining the curriculum, Adam wrote the code, and as we can see, it ran successfully. Let's look at another simple program that adds 2 integers. This is very similar to the previous Hello World program. We see an obvious difference at printf. With printf, we can not only display simple text, but also the result of a mathematical expression. The %d will be replaced by the result of our expression. %d indicates that an int type value will be replaced. For floating point numbers, we have to write %f, for characters %c, and for strings %s. The result of our program can be seen on the screen. In the stdio directory, there are many other useful functions beside printf. We will now learn about 2 more functions that you will use in later sections. These are getChar and puts functions. Let's look at an example of what they can be used for. The int getChar void function can read a character from the standard input, such as from the terminal using a keyboard or file. The function returns with the scanned character and does not have an input parameter. The following simple program demonstrates its use. When we start, we create a variable called C in which we will store the character scanned from the terminal. We use a text message to indicate to ourselves what to do, what the machine is waiting for. When our program reaches the getChar function, it will wait until a character is pressed, then the Enter key is pressed. After pressing Enter, our program continues with the following command, which will also be a text message. To check our program, we will print the previously scanned character, and with that, we reach the end of our program. On the screen, we can see the result. The program waits for the character and then displays it on the screen. With the int_puts function, we can send a string to the standard output, screen file or printer. The function expects a string as an input parameter. You may have noticed that if we only print something, then why is there a return value? In the return value, we get information about the state of the function's run, whether it was successful or not. The following simple program illustrates the use of this function. We create a string called text, where we put the phrase "I am a string." The string is passed as a parameter to the puts function, which prints the text we have given to the screen. If you remember, I promised that we will see how to use the function we wrote. Our last example will show you this. The functions we have created are located outside the main function. We have seen many examples of calling a function. Let's think about printf. The following code contains the previously presented add function and its usage. When we look at the main program, we can see that our function receives two integers that correspond to the list of parameters. For example, in case of add 1, 4, the first number will be replaced by 1, while the second number will be replaced by 4. In each case, the result will be stored in a variable called result. It can be seen that we can call the function as many times as we want. We just need to refer to it and give it the right parameters. The output of the program can be seen on the screen. With this, we have also completed the understanding of the basics of programming and the C language, and have completed our first programs. Of course, the C language has more complex elements, which you can get to know if you have enough enthusiasm. Feel free to study the curriculum.
In an industrial environment, the programs are so complicated that it is near impossible for a single individual to understand it all. Let's talk about how this is done in practice.
First, we divide the whole system into subsystems, and then those into even smaller sections. This is called modularization.
These smaller sections, also known as the modules, are easier to comprehend, and therefore developing and testing these are much simpler than developing the program as a whole.
These modules have to work together, therefore it is important to define the connection points and the interactions between them. These are called interfaces.
If we implement these modules and interfaces correctly, then it will be easy to replace the modules or to reuse them elsewhere. Furthermore, adding new modules and features to our program will be easier later.
In a large project, the modules are developed by different companies, and the project is led by a software integrator whose task is to connect the separate modules into a whole system.
This process is helped by industry standards. In order to maintain the source code, version control systems are used. By using them, we can track modifications and save different states of the program, which can be easily restored later on.
A rudimentary way of doing this is to copy the actual state of the program each day into a folder whose name is the current date. However, this can only be maintained if we are working on the project alone.
Maybe a better solution is to use an advanced version control system. That way, the source code is stored at a central server, which can be reached by every single developer. A great advantage of these systems is that we can create different development branches. This way, each feature can be developed on its own branch independently of the others, and later, when completed, the branches can be merged to form the whole program.
For example, if you want to try handling a peripheral with polling and with interrupt, we can create separate branches for these on which we can experiment. We will see later examples of using interrupts in the 21st chapter, titled Immediate Events in the Software, Interrupts.
We advise you to experiment with version control systems, as in the field they are unavoidable. There are free-to-use systems such as SVN and GIT, which make software development easier with many more features.
This was the last video of the Crystal Clear Electronics series 10th chapter. We hope you learned a lot about information technology. I wish you the best of luck for the upcoming programming-related chapters.
I would like to thank Szabolcs for the presentation and the summary of programming. The curriculum can be downloaded in PDF format from crystalclearelectronics.eu and in Hungarian from kristálytisztaelektronika.hu. You can find a mobile app for Android and iOS platforms under the same name. You can also follow us on Facebook for the latest news, and hope we soon meet you in the next video. Bye bye!
Sziasztok! Akkor még le kell játszanunk a sokkot. Legyen hosszú part.